Hi guys, Mrs. Warner. It's exciting lesson number 2 of roots and radicals. Today we're going to add and subtract radicals. I know you're excited. We're going to stick with square roots. I'm going to double check our final and make sure there's not a lot of cube roots on there, but I'm pretty sure we're just adding and subtracting square roots on the final exam. So we're going to stick with those, which will make everybody happy because square roots are a little easier than cubes. Okay, so these are not bad at all. I think you're going to like them. Okay, so the first thing we're going to do is look to see if the radicands are alike. So if you look at example 1, the radicand is the number underneath the radical sign, and they're both radical 5. That means they're alike. So since they're alike, we can simply add or subtract the coefficients that are in front of the radicals. So I'm going to take this 2, oops, I need my pen, not the eraser. This 2 and this 7, add them together because that says plus on there, and that gives me 9 radical 5. So I don't change the radicand. The radicands were the same, so I could add them together. Piece of cake. Let's look at the next one. They're both, all 3 of them now are radical 3s. That's great. So I'm going to do 5, take away 2, which is 3. And then you have to realize that there's somebody in front of here. There's a 1 in front of there. So 3 plus 1 is really a 4. So now this is 4 radical 3. That was easy. Okay, now looking at the next 2 examples, they're not alike. One is radical 2 and one is radical 18. So what I need to do is simplify the radical 18. So I'm going to keep radical 2. I'm going to change this guy to a square root of 9 times square root of 2, because 9 times 2 is 18, and 9 is a perfect square. So now this is like 1 radical 2 plus 3 radical 2, and now they're the same radicand because the square root of 9 was 3, and I keep my radical 2 the same. 1 and 3 make 4 radical 2, and that's my final answer. Let's try another one. 5 radical 3. Not much to do there. The 3 is simplified, but the 27 can break down. So I've got 5 radical 3. 27 is 9 times 3. Okay, so now that's 5 radical 3 minus 3 radical 3, and 5 minus 3 is really 2 radical 3. Piece of cake. Let's keep going. Now I've just got 3 radicals, but that's okay. I can do it. So I've got 3 radical 8. Well, the 8 is not simplified. 8 is 4 times 2. So that's 3 radical 4 radical 2. Now, there's a 3 outside there. He's going to multiply by this square root of 4, which is really a 2 radical 2. So this whole piece is now 6 radical 2, and that's just the first term in the problem. I have 2 radical 18. So that's 2 times radical 9 times 2. So now the 9 pops out to become a 3 out of the radical 2. So it's plus 6 radical 2 again. The 4 radical 2 doesn't need to be broken down, so I'm just going to carry that down. Well, 6 plus 6 is 12, minus 4 is 8 radical 2. And that's my simplified answer. Who put those fractions there? Mrs. Warner did. We can do it. I've got 1/3. I'm just going to leave that there for now. Square root of 45 is 9 times 5. Well, really, that's 1/3 times 3 radical 5, and 1/3 of 3 is 1 radical 5. That wasn't bad. Now let's go over here. I've got 1/4, and 20 is 4 times 5. So now it's 1/4. Oops, just kidding, Mrs. Warner. Times 2 radical 5, and 1/4 of 2 is 1/2 radical 5. So really, I have 1.5 radical 5, or you could think of that as 3/2 radical 5. And that's my final answer. And that was fun. And that concludes our lesson number 2 notes on roots and radicals, adding and subtracting radicals. Have fun doing your homework. Bye. Later.